Today we will go over tangent lines of a circle and the properties, theorems associated with it. So let's start with the definition. A tangent line is a line that intersects with a circle at exactly one point. What this means is, if I have a circle, you have a line sitting on top of that circle. It's touching the line only, the line is touching the circle only at that point. It's sitting on top of that point. So that's called a tangent line. So we have a few properties related to tangent lines. First, if a line is tangent to a circle, then it is perpendicular to the radius at the point of tangency. That's a word here. Point of tangency is what you call that point where the radius and the tangent line meet. So the radius and the tangent line make a 90-degree angle. So let me write that down. The radius is perpendicular to the tangent line. So let's look at an example back here. In this example, segment AB is tangent to circle C. Solve for x, given these equate numbers. Because it is tangent, since AB is a tangent line, what this means is AB is perpendicular to CB. In other words, angle B is a right angle. So there you go. That being a right angle is what lets us use Pythagorean theorem. 15 squared plus x squared equals 25 squared. Solving for Pythagorean theorem, I can do 25 squared minus 15 squared and square root that number. X equals 20. So my radius is 20. Second theorem. Two tangent segments from an exterior point of a circle are congruent. What this means is, if you have two tangent lines that cross outside the circle, then this segment from A to B and this segment from C to D have to be congruent. So let's take a look at an example. So over here we have the radius of circle C is 39, and we're asked to solve for AB, DC, and AC. So radius is 39. Radius is a line that goes from the center of the circle to a point on the circle. So this is a radius at 39. Down here is also a radius, also 39. Next we have tangent lines, since we're still going over tangent lines. So we have this line tangent to there, there's a tangent line, and another tangent line. Because I have two tangent lines that intersect at point A, what this tells me is AB is congruent with AD. So if AD is AD, that means AB is also AD. DC is a radius, so that's 39. Last part, AC. AC would be this line right here. Again, same thing over here. AB is a tangent line, which means B is a right angle. AB is a tangent line, which makes this a right angle. So we have a right triangle now. If we turn paper sideways, here's your right triangle. AC is your hypotenuse. So we have 39 squared plus 80 squared equals, let's go ahead and call this part x. X squared. So what I can do is 39 squared plus 80 squared and square root that number to get x equals 89. Alright, so there you have it. The idea here is that important part here is AD is congruent with AB. Third theorem. The line through an external point and the center of a circle bisects the angle formed by the two tangent segments. What this tells you is if you have two tangent lines, then the line from the center to where they meet, AB or OB, is an angle bisector, which means this angle is congruent with this angle. ABO congruent with CBO. Alright, and that's all we can say for that. Next up, let's take a look at some arcs over here. Tangent and secant formulas. For now, we'll focus on the tangent parts. Tangent would be this last one, tangent. So this is tangent. This one over here is secant. So we'll focus on the tangent part. We have this formula. Given this setup, measure angle K equals far arc. When we say far arc, here's my angle. My angle has two intercepted arcs. One right here, which is near, and one all the way over there, the far arc. So angle K equals angle K equals your far arc minus your near arc divided by 2. Again, angle equals far arc minus near arc divided by 2. Or another way to express this formula is 2 times your angle K, double your angle, equals far arc minus near arc. 2 times angle K equals far arc minus near arc. So let's do an example using that concept. Over here, using my formula, I have angle K, in this case it's X, equals, let me write them down, angle equals far arc minus near arc divided by 2. So let me move this text down a bit so I have room. Okay. So my angle is X equals far 260 minus near 100 divided by 2. So X equals 260 minus 100 is 160 divided by 2. X equals 80 degrees. Alright, so that's demonstrating this concept. Another concept we can take a look at is there is a relationship between near arc and angle. Let me write that down over here. For tangent, this only works for tangent. Angle K plus near arc equals 180 degrees. So let's take a look at that. Let's take a look at that example over here. So this arc plus this angle equals 180. Solving for x. X equals 50 degrees. So 50 plus 130 degrees equals 180 degrees. Alright. So there you have tangent lines, its different properties, and examples over here.